Yes, so just a little bit of introduction. So I'm working on GNU Guix, which is a universal package manager. So we have very specific goals and a specific Grail, I suppose, which we share with some other projects, but maybe not entirely, or we have different things. I'm actually into packaging since maybe 12 years or something, which is kind of ironic because when I got started into free software and GNU Linux, I always thought that packaging is uninteresting. So it's like, yeah, but it turns out that yeah, there are lots of things to do, and it's actually pretty cool. So let me first introduce our own packaging grade, and then we'll see how it compares to others. So Geeks is a GNU project. We insist on providing free software, so software that users can study, can run as they wish, can modify and redistribute modified copies of. So free software is very much at the core of Geeks, pretty much like Debian in a way, and like a whole bunch of other distros like Triskel. Because we want free software, that also means we're providing a curated distribution. So it's not like if you want to add a package to Geeks, you have to go through a review process that goes with it. So review goes beyond just checking whether it's free or not, but that's part of it. The second thing is we're trying to build a universal package manager, which means that the world is not monolingual. There's software written in lots of languages, and you want to be able to install that software, whether it's written in Python, in Rust, in C, etc. So that's what we're working on. Pretty much like the traditional Linux distribution, like Debian, Fedora, and so forth. The last one is we're trying to build a transparent distribution. So that one is a bit more, perhaps more difficult to understand and to share among the different package manager communities. So let me explain a little bit. So I said we want to provide free software, so we also want to make sure that our users who install software via Geeks can get the source code of their software, right? So that's one thing. Being able to have some provenance tracking. There are some connections with user freedom, but also with security. Like if you want to be able to know what software you're installing, so you want to be able to have a link between the binaries you're running and the actual source code that it comes from. But to do that, we need reproducible builds. So you've probably heard of the reproducible builds effort, where many distros come together, many package managers. The idea, so it's called reproducible builds, but the idea is really to provide deterministic builds so that users can actually verify binaries, right? So the whole point is not reproducibility for the sake of reproducibility, but rather being able to provide verifiability of those binaries that we run. So what does it mean concretely for Geeks? So in Geeks, for example, we have a command that's called Geeks challenge. So let's say, so Geeks allows you to get pre-built binaries, right? So let's say you have different servers providing binaries. You want to see which one is trustworthy, whether one of them is not providing the right binaries. So you can run Geeks challenge, and it's going to tell you, look, we have, for example, OpenSSL that's different on the first server than on the second server, and your local build is the same as the first server, but different from the second server, for example. So you can compare. You can say, all right, maybe something's wrong with the second server, and same for Git and Pius and so on and so forth. So it allows you to actually challenge those binary providers. You can check whether they're really providing the right binaries, and if there's a difference, then something must be wrong, right? This is made easier by the functional model that Geeks implements, and which is inherited from Nix. So Nix pioneered the functional packaging model. And in a nutshell, it's just like, imagine you have Emacs, a package, a binary, and you're just viewing it as a function, as a pure mathematical function that takes a number of inputs, GTK, GC, make, etc. And Emacs is the result of that function. So the function is basically running configure, make install, for example. And you're defining all your packages that way, Emacs, GTK, GC, and so on and so forth. And on top of that, when you're building software with Geeks, and same with Nix, all the build is happening in an isolated environment, so with chroot, separate namespaces, and so on and so forth, such that if you look at the result, it's going to be a bit identical for everyone, because by definition, we are building in an isolated environment precisely to maximize the chances that the result is going to be deterministic. All right, so that's one thing. Reproducible builds. But to have reproducible builds, you need to have something to build in the first place, right? So the next effort is called Bootstrappable Builds. And again, there are Geeks people inside that effort, but there are also people from different backgrounds, different projects working on these issues. So Bootstrappable Builds is a fancy way of saying we want to build everything from source, right? So we don't want to have binary blobs anywhere, because otherwise those are not auditable, right? So if you've heard about Reflections on Trusting Trust by Ken Thompson, that was some 40 years ago. Ken Thompson in this lecture demonstrated that you can have a compiler with a backdoor that propagates itself every time you recompile something. Right, and that's the kind of issue we want to avoid, you know. And it's not just an academic exercise, right? It's not just theoretical. It can have very concrete impacts. So, for example, we know that the CIA toyed with the idea. There have been several experiments. For example, an experiment on the Rust compiler to try to introduce a backdoor and reproduce it using the trusting trust attack. Another experiment using Clang LLVM, for example, and exploiting this time bugs that already exist in the compiler, but it's kind of a similar attack. So it's not theoretical, it's a real software supply chain issue that needs to be solved, in our opinion. And to give an example concretely, this was the dependency graph for the first package that we built in Geeks, which is GNU Make. It used to be that way, right? So you have GNU Make at the top, and it depends on a whole bunch of binary blobs. So we have one big binary blob for glibc, for GCC, for binutils, etc. And this is how it used to be. But that was 250 megabytes of binaries, unauditable. So what we did is that we changed that graph to, instead of relying on a big binary blob of GCC, glibc, etc., we start from a simpler compiler. So the first compiler is called MESCC, part of the GNU MES project. And from there, we build a slightly more complicated compiler, sophisticated, TinyCC. And from there, we build GCC and so on and so forth. So the dependency graph is larger, right? But the good thing is that we've gone from 250 megabytes of opaque binary to 150 megabytes of binaries. And then we went further, again replacing other pieces of the dependency graph, such as the shell and core utilities, which allowed us to reach 60 megabytes of binaries. That's where we are today, but there is ongoing work to maybe at some point reach 0.5 megabyte of binary blobs. This is at the horizon. You can watch this FOSDEM talk by Janneke on this topic. All right, so these are the things that make me happy, you know. This is the Grail for me and for the Geeks project in general. Yeah, that's the ideal. All right, but then there's real life. You have to actually provide packages, right? So recently I was working on packaging PyTorch for Geeks. So PyTorch is a neural network framework. Because, you know, I had colleagues needing it, so I needed to work on it. And that turned out to be kind of a nightmare for me for many different reasons. I'm sure there are people in the audience who can sympathize with that. In a nutshell, so you can find PyTorch and PyPy, but it's mostly C++ code. It has tons of bundled dependencies. It's hard to unbundle them, but we want to do that in Geeks for transparency reasons. Some things are non-deterministics and so on and so forth. So that was kind of a nightmare. But anyway, I managed, so you can now run Geeks, install Python PyTorch, and we have this wonderful dependency graph. So I was quite happy, but then I went to my colleague's office next door, who's doing AI stuff. And I said, I managed to package PyTorch for Geeks. He was much less enthusiastic than myself, but so I said, how do you install PyTorch these days? He said, well, I just run pip install torch and it's very fast and it works. And indeed, it's super fast, super convenient. So it downloads 800 megabytes of archive, and then you have something that should work on most distros, maybe not on Geek system, but on most other traditional distros. So I looked more closely into that to understand how they managed to actually provide that, that package that just works and that you can install very quickly. Because I thought that pip was a Python only package manager, but obviously PyTorch is not only written in Python. There's a lot of C++ in there. So I started diving into that. So if you download the file, the wheel archive, it's actually a zip archive that pip install downloads, and you look what's in there, you find that there are a lot of binaries, a lot of shared libraries. In particular, there are things like CUDA, which is NVIDIA's proprietary software for GPUs. And there's libgomp, which is GCC's offloading library. And that's kind of weird. You don't expect to see that in a PyTorch package, right? So I was kind of shocked. How come these things get into that? So long story short, if you look into more details, so there are several problems with that. First, you're getting non-free software which you did not expect, right? And you're getting the big issue is that you're getting random binaries, in the sense that you cannot verify that all these .so file actually correspond to PyTorch or to libgomp, etc. It's just too hard to reproduce them and thus to verify them. And there are licensing issues. For example, for libgomp, they should be providing the corresponding source. Lots of problems. Those binaries were developer uploaded, which means that the PyTorch developers can upload directly to PyPy their binaries. Well, this is pretty brittle. Well, I spared you the details, but you can look at that blog post. The URL is at the bottom for more details. All this is convenient, but as you can see, it's pretty far from my Grail, packaging Grail. But it's worse. So Torch on PyPy is a binary-only distribution, so that's kind of a problem because you cannot verify it, like I said. But even for packages on PyPy that provide source, well, sometimes the source does not correspond to the actual upstream source. So you get a package from PyPy that contains source that's actually slightly different from the upstream source because, people can upload packages. It's not curated, it's not peer-reviewed, so, things happen. And this paper about last PyMile is precisely about that kind of issue and the supply chain security issue that can arise as a consequence. So I'm talking about PyPy, but obviously it's not just PyPy. I won't even go into the details of NPM. You've probably heard about the left pad chaos issue some years ago. There are other problems, like recently the UA parser.js package that was hijacked because, it's just, again, there's no curation on NPM, so anyone can basically upload things and you can get compromised. There are other issues like the fact that npm install actually runs arbitrary code, which resulted in a bunch of CVEs recently. Lots of problems. So that gives me an unhappy face. So I think my thesis is that all these packaging practices, so the fact that people are bundling lots of software, the fact that people are creating new package managers and also, trying to live in their own world, they mirror isolation, right? In a way, there at some point people don't want to work with too many different people. They don't want to interact with too many different people. So the easiest way, for example, is to bundle the dependencies you rely on instead of doing it the normal way, which is just to say, well, look, my package depends on some other package. And the same happens with language-specific package managers. There are many of them, and it's very nice from the language community viewpoint, because it allows you to grow the community very quickly. But the downside that we have lots of islands, basically, of different languages and tools. So the question then becomes, can we go from isolated islands to archipelagos, which means, coming together and working together? And this packaging conference is, of course, a good opportunity to look into that question. And actually, that was one of the main questions of the panel right before. So, it's my birthday next week, so I have a message, a wish list for repository maintainers. I hope it's not a message in a bottle. So, how can we move forward? So I would say it would be great if repositories like PyPy, for example, would explicitly move non-free software out of the way, like in a separate repo or something, or remove it entirely. That would be my preference. But people sometimes want to use non-free software. So if at least things could be separated so people can make informed choices, that would be great. That would be a great first step. Then for PyPy specifically, I would like it if PyPy would provide always source releases, so no binary-only dist releases like we have for PyTorch. And again, disallow developer-uploaded binaries. So that was one of Debian's dirtiest secrets, in the words of the former Debian project leaders. Several years back, Debian allowed developer-uploaded binaries. That's no longer the case, I think. Because it's then, if a developer is compromised, then you can end up distributing compromised binaries to everyone. And that's a problem. And if you do provide binaries, then it should be reproducible, verifiable. Anything else? Yes, if we look specifically at the case of Geeks, but I guess if you look at other tools like Spack or apt, etc., well, the situation is similar. So today, Geeks has almost 20,000 packages, and more than half of them actually come from all these language-specific repositories. So we have Rust, Python, PyPy, CRAN, Emacs Lisp, etc., etc. So if we can actually, make sure that we have a common language between those repositories and downstream package managers like Geeks, then we can make great progress, I think. So in Geeks, for all these tools, for example, we have a Geeks import command that allows us to import and to convert the package from the upstream repository into a Geeks package. So if we do that with the WebAsset package from PyPy, we get, well, a Geeks package. And that's great, but if we look more carefully, that one is not quite perfect. So for example, we had to modify it to add a couple of dependencies. So for example, we had to specify more dependencies so that we would be able to run the tests. We had to specify additional arguments on how to run the test, things like that. So that led me to the question, how good is the data, the metadata that we get from PyPy, from crates, and so on? So I ran a quick experiment this week by basically rerunning our Geeks import command and comparing it to the packages that we actually have now in Geeks proper. And the idea was to see, to what extent we had to manually modify the package definition that we imported from PyPy, from CRAN, etc. So I only grabbed, I was only able to get a few figures, but just to give you an idea. So for CRAN, for example, CRAN is very good. Like in 85% of the cases, we don't have to modify the package definition at all. Like it just works out of the box. For crates, it's kind of similar. For PyPy, it's much less. So for PyPy, we very often, like 70% of the time, we have to modify the package definition that we get from PyPy. So why is that? So the common issues that well, one issue is when the hosted source differs from the upstream source. So when PyPy gives you a source that's slightly different from what's in the upstream repository, like for example, it lacks unit tests. In some cases, of course, you have issues with missing foreign language dependencies, like Python software dependency, or you have missing test dependencies, like you need to add PyTest, stuff like that, or you have specific test procedures, and PyPy, for example, doesn't tell you how to run tests. So if I want to augment my wish list, I would say, please provide accurate package data. That's already getting better and better, but in some cases, especially PyPy, we can do much better, I think. And on top of that, it would be great to have good licensing info. That's not always the case, and even it would be perfect to have nice descriptions and synopsis. Turns out that this wish list is shared by many people. There is Microsoft, for example, I just learned, has a team working on precisely these issues on PyPy, NPM, and other repositories. And there's the executive order of the US government on improving the nation's cybersecurity. It has specific points on software supply chain issues. It's actually surprisingly technical. But people are looking into it. So to wrap up, I think package managers have become kind of a source of our supply chain issues. That's very clear in the case of NPM, for example. There have been high-profile issues, but then they're also the solution to these issues. And I think we can work together to address these issues by improving the quality of the data, and the quality of the processes that lead to those repositories. And this is it. I think I'm right on time.
All right, thanks, Ludovic. I think we do not have time for questions, so I'm going to go to the next talk. Thanks a lot. Okay. I guess actually let's do one. Let's do one question. Yep. Let's see. How did Geeks deal with PyTorch's non-free software dependency?
So currently it does not deal with PyTorch's non-free software dependencies. So the official PyTorch package in Geeks proper is CPU only, so it's not very useful for some big data sets. But I suppose people are going to create variants of that package that use CUDA, for example, or that use AMD's WorkM tools.
Okay,